Hey, what's up everybody? Welcome back to another layer by layer tutorial. In today's tutorial, we're going to find out how to make easy snap fit enclosures. These type of enclosures that I make are normally a two-piece design where the enclosure piece has these nubs on the side, the inside of it. They're these kind of nubs, and they connect and lock into this top piece where the top piece has this protruding lip, and the lip has this sort of geometry where it locks onto the nub. So if we look at this enclosure cross section, we can see how it's working. Because there's the nub is basically fitted and locked into this area. But there's a little bit of tolerance here. There's a little bit of gap, as you can see. And that gap is necessary when you're 3D printing something. So this is really good for 3D printed enclosures. So we're going to learn how to make these a lot easier than our previous tutorials. So let's make a new design, and the first thing I'm going to do is create a new component, and I want this component to kind of contain the two pieces individually. So I'm going to call this enclosure. And then what I'll do inside of enclosure, I'm going to make two more components, and this one's going to be the case, which is going to be a separate piece, and then another one inside of the enclosure. I'm going to call this one the top cover. This ensures that if we ever need to add on to our enclosure, maybe we need a bottom cover or we need a mounting thing, all of that can be nested inside our main enclosure. So just to kind of structure your project this way is really, really helpful and healthy. So I'm going to start off with the case, because that's what we're going to make first. And before I start drawing anything out, I'm going to bring up my change parameters window. This is the user parameters. And we're going to create some parameters to make it easier for us to adjust this design. So what type of parameters? Well, for example, the width. So I'm going to make this width 50 just for now. We'll change it later. We're going to make the length of the enclosure. We're also going to make it 50. We're going to make the height of the enclosure. Let's make that 25. And then we're going to make the shell of the enclosure. I'm going to put 1.5. And then we're going to make the gap, which is our clearance or our tolerances that we'll create. That's going to be 0.2 millimeters. So again, we got the width, length, height, shell, and gap. So those are going to help us kind of quickly create this thing and change it. So I'm going to hit OK. Next thing I'm going to do is I'm going to draw a sketch right on this grid here on the bottom. And with that created, I will start drawing my rectangle. I use the R key on my keyboard to bring up the 2-point rectangle. And I'm going to start it from the center here so it locks to the center. I'm going to draw out. Instead of clicking and then adding it, I'll just type in length here at the bottom. Hit tab, and then this will be width. All right, so now it's 50 by 50. Now that's set. I'm going to click on that rectangle, hit E on my keyboard for extrusion, and then I'm going to type in height, and that'll make it the height. So now I have my box, and we can start adding some stuff to it, maybe some fillets. I'll look at it from the front view, hit the F key on my keyboard, and then I'll create a marquee selection by clicking on the right and then dragging to the left. Let the thing go, and then it selects all 4 edges easily. So now I'm going to add a value here, maybe 3 or maybe 4. I hit OK. So now I have my nicely filleted box. Next thing I'm going to do is I'm going to add a shell to the top here. So I'm going to click on the top, right click, and shell is right there for me in this little drop down. So I click on shell. Instead of typing some numbers, I'm going to type in, well, shell, because that's already set up for us. So it's the 1.5 millimeters that we made. So now that we have our box, we can play around with the diameters or the dimensions. The length, for example, we should probably make it a little bit longer just to kind of go with the name, so it's long. And you can see that it updates really nice. I can also change the height to something a little bit taller, maybe 30. All right, so now that we know that's working, we can also change the shell, of course. Maybe we want it a little bit thicker. Maybe we want to change it back to 1.5. That works well. I haven't used gap yet, but we're about to use it in a little bit. So now that we need to find out, or the next thing we need to craft is the nubs on the inside of our cases. So it's up to you to figure out which actual ones you want. I'm only going to make 2 of them, and I'm going to pick the left and the right sides. They're left and right because they are labeled such here, like in the view cube. If I click on left, you can see that's the left, and this is the right. Or you can do it on the front and the back, but it doesn't really matter. So I'm going to start up on the left here. I'm going to select this edge or this surface because that's where I want the nub to protrude from. So I'm going to start on that. With that selected, I'll create a new sketch, and that'll create a sketch right on top of that surface and kind of project that. And I'm going to use the rectangle tool again, And I'm going to draw on top of this edge. As you see, my cursor changes and it gives me this little X. That lets me know that whatever I draw is going to have a collinear constraint locked to this. So basically it's saying that whatever I draw is going to stay locked there. So I'll give you an example. So I'll click here and I'll draw out sort of a rectangle here like that. There's no dimensions set to it. But you notice that the top here is kind of black, and that lets me know that I have a constraint set there. And the constraint, again, is this guy over here. This little icon, and that's a collinear constraint. So that was automatically applied to me. So whenever I drag these corners, you can see I can manipulate I can freely manipulate it, but what's always happening is that edge is locked to this edge. And again, that's done with this collinear here. When I click on that edge, this icon shows up. You see that? Let me do it again. Click on that edge, and then this shows up. And that lets me know that that is a collinear constraint because it looks like that. If I delete it with it selected, I can hit the delete key, and that'll break that relationship. We don't need to do that here. Okay, the next thing I'm going to do is I'm going to create a height for this nub. With that selected, I'll hit the D key on my keyboard to make a dimension. And I'm going to make this actually the width of the height of this is actually going to be driven with the shell, but I'm going to make it double the shell. So I'm going to say shell multiplied by 2, just like that, and it makes it 3. That's nice. And I'm going to do kind of the same thing for the width, and click on that, bring it out, but instead of adding a number, I'm going to say I want this to be the width divided by 2, and that'll give me 25 because I think it's 50 right now, the total width. So now I have those locked, but it's still free to move. I can still move this and it kind of stays locked, but it can move outside of the case. So to constrain this to always be inside of the case, I want it to be to the center of this. So to do that, I'm going to use the line tool and I'm going to create some construction lines. So to do that, I'm going to hit the X key, and that'll turn the construction line mode on. And as you can see, you can turn it on and off here. So what I'm going to do is I'm going to find the center of this edge by rolling over until I get this blue triangle, and that lets me know that's the midpoint. So I can click on that, and as you see, as I drag, my line is dotted lines, and that's letting me know that I have a construction line going on here. I haven't applied it yet, but what I'm going to do is I'm going to try to find the center point of this line here, which is our nub, and there's the center point right there. Now, it's still free to move. I can still move this around, which is not good. I actually did this wrong. I'm going to delete this. And the reason why it's wrong is because I was saying from that to this always be centered. That's not what I want. I'm actually going to move this away over here. And I'm going to say, again, with the line tool, I hit L for the line tool, and then X to turn on the construction line. I'm going to roll over this. Because what I want is I want this line, not this line yet. So I'm going to click on that, and then I'm going to go over to the bottom line of this, and then click on that. And now you can see that when I move this around, that line is moving with it. Well, to lock that line straight on, there's a construction constraint rule called the horizontal and vertical. And when you click on that with something selected, it'll just make it either vertical or horizontal, perfectly straight. And now it's fully defined, so this is locked. I can't move the corners anymore, and it's perfectly lined up and centered because we have those construction points, like the midpoint is automatically applied for us. So it's following its rules, right? Next thing I'm going to do is I'm going to extrude this out, this rectangle, and if you add some distance to it, you see what it's doing. And normally what I would do is I would hit OK and then add some chamfers to this. But you can actually, if you hit the tab key, you can actually do a tapered angle. So that's where you kind of get this dealy going on, right? So what I'm going to do is I'm going to put negative 45 degree because 3D printers can print 45 degree features. And that's going to, not only does it make it chamfered on the top and bottom, but also chamfers it out on the edges here. So you see that edge actually gets brought inward, which is really helpful for the machine as well, the 3D printer. So I'm going to hit OK. That joins to it. If I double click on that extrusion, you can see it is operation join. So it's joining to the case is what you want. And that's pretty nice. And if we were to test this out, let's go ahead and increase the width to like 65. You can see that it automatically updates when you apply that expression, that number. So that's really nice. You can go lower as well, and it just shrinks with it. So that's really powerful. And it's always going to stay in the center because those midpoint constraints that we built earlier. And it's always going to stay at the top as well because we have it locked with collinear. So if I change the height to 25, it'll actually drop with it. And if I increase it again, it goes with it as well. So that's pretty awesome. So it's a great way to kind of test if your stuff's working out. The next thing we want to do is, all we want to do is we want to copy this nub and throw it over here and lock it to that area. Easiest way to do that was with the mirror command. Is that you can just mirror that. But before we need to find out what the middle point of this and that surface are, those two surfaces. We can use a construction plane called Midplane, which will create a midplane between two work surfaces or two faces. So it's going to be this face, which is where our original nub is, and this other face where we want the nub to be. And of course, they're both on the outside of the case, not the inside. They could be on the inside, but it doesn't matter. So now that we have that, we got to hit OK. And now we have this kind of midplane that we can work with. So I'm going to bring up the model toolbox with S. That lets us kind of search for things. I'm going to search for the mirror command. There it is. Click on that. And the pattern type, I want it to be features. Because normally what I would do is I'd have faces, and then I would click on each individual face and like do that. But I don't have to do that. I could actually just say features. And then I can select this extrusion feature. And if I had other features, I can actually select multiple features as well and mirror those. But I just need this one. And then for the mirror plane, of course, it's going to be the one we created just now, which is that one there. You even get a little ghosted preview where it's going to go. And I'll hit OK, and it gets added. So the powerful thing about this is that it's just mirrored. So if this enclosure height or width, for example, changes, yep, they both change. So that's really nice. Now, the next thing we're going to do is we're pretty much done with the case in terms of like the nubs. We can work on the top cover. So when I select that, I activated the top cover component, and this kind of turned into a ghost. Lets me know that I'm in a different component. But we can still reuse things from the case component. We don't have to kind of recreate any of these things. So what I'm going to do is I'm going to select this top surface or this top face of the enclosure. And that's where I want my cover to start from. So with that selected, I'll create a new sketch. And I'm not going to draw anything in here. I'm just going to hit OK. I'm going to select that inner profile and the outer profile. With them selected, I'll hit E on my keyboard, and I'm going to make this about 2 millimeters thick. And you see it's pulling up. That's good. I don't want to bring it in because then it intersects with it. So I want it to be 2 millimeters going up away from the enclosure. It's going to be a new body, so I'll hit OK. So now that I have that, well, what's really good about doing it this way is that if I were to change, again, if I were to change the width and stuff, it's being driven with the geometry from the case. So the cover will always update and always obey the geometry from the case because it's being driven from it, as you can see here. The next thing I'm going to do is I need to create a lip that will kind of mate and lock onto those nubs from the case. I'm going to hide the case for a second. I'm looking at it from upside down, and I want the lip to protrude from this surface, not the top, but the inside here, the bottom. So with that selected, again, I'll make a create sketch. And what I'm going to do is, now that that's a sketch, I have this thing. I want the lip to be an offset on the inside of this. So there's an offset tool. It's called O, or up here under sketch, it's going to be called offset. I just use the hotkey O. And then I'm going to select this outer edge here. And I want to make sure that chain selection is on because it'll select this whole loop. I'm going to click on that. Now it makes it out. I actually want this to be inward by a certain amount, and just to kind of make Fusion understand things, I'm gonna hit OK. And if I double click on this dimension that we set, because it is an offset, we can modify the offset. I actually want it to be driven with this shell, and I want to add gap to that shell, and that'll make it 1.7. That's because the gap is 0.2 and the shell is 1.5. So if we ever need to change the shell or the gap, as you see that I'm doing now, it will update that automatically for us. So that is really important to know the relationship between those two. Okay. So now that I have that, I'm going to go ahead and extrude this inner profile. I'm going to extrude this inner profile and drive it again with shell multiplied by 2. And that gives me, I think, 3. Yeah. So now that I have that, if I bring back the case, you can see that the nubs will intersect with that sort of meat area, the inner area. So we need to create an indentation, a cutout. So we can do that by using the sketch that created the nub. So I'm going to hide this. I'm going to bring back the sketch from the case, right? I'm going to turn that on. I'm still inside the top cover. As you can see, it's active. But it doesn't mean I can't use sketches from other components. So I'm actually going to select that nub profile, hit E on my keyboard. If I look at it straight on, you can see that that gap is kind of affecting this, right? So what I'm going to do is I'm going to change the start profile plane. I'm going to change that to from object, and this will let me select a starting point, a starting surface. So I want the extrusion to start from this surface, and you can see that if you look at it on the side, it is now starting from there. So now I can do my shell times 2, and then I can tab and then put -45 degrees, and it makes that geometry. I hit enter pretty quick, but that's just cutting that object. So now if I bring the case out, you can kind of see through the ghost that there's a perfect 0.2 millimeter clearance between all of those faces. We can even do a cross section by using the section analysis tool under the inspect drop down, and then I'll click on this face, for example, and then just bring this inward, and then you can see in between inside the case here, and yes, there is a clearance of 0.2 millimeters across all the surfaces, including the side surfaces as well. Just kind of can't really see it there. Next thing I'm going to do is I'm going to optimize this for 3D printing. Or actually, no, as you can see, I didn't do it for the other side yet. So that's easy. All we got to do is apply a mirror. So let's do that. I'm going to turn off the section analysis, and I will hide the body for the case so I can just get a better look at this. So I need to bring up the sketch model toolbox, type in mirror, select it, and then I will select that feature, which is right here, that extrusion. I need to select the mirror plane, which is this midpoint from the case. The case has that, remember? So that's why it's a little bit faded out. But anyway, you can still use it. I clicked on it, and I'll hit OK, and there it is. So now I have my mirrored feature. The next thing I'm going to do is I'm going to create a shell right on top of this surface. So right click on that surface, shell, and of course use the shell parameter. Hit OK. And take a look at that. Fusion does such a great job with the shell that it even kind of shelled around this geometry here. So if I were to select like this bottom face and this face, you can see the distance is, 1.5 millimeters, which is our shell. So it's dynamic like that. The last things I'll do is to make this a little bit more easier and less kind of frictionless, kind of reduce the amount of friction and the amount of stress when removing and adding the enclosure. You can add some fillets to this area here, some chamfers actually. So I'm going to click on that edge, type in chamfer, and then 0.6 is usually what I do, 0.6 millimeters. Because any more than that, and the thing might not lock onto those nubs. So I'll do one over here as well, just like that. And you can see it's being applied to that, because that's really where the nubs are going to meet. So if I were to bring up, let's go ahead and activate the entire assembly. That way we can look at our things here. So if I were to move this up, you can see kind of how it'll click in like that. So it kind of has to flex a little bit. So having that shell right here really helped out, making it so that this kind of flexes a little bit and locks in like that. Hit the revert thing. So that's pretty much it. Now, this is really kind of the least amount of steps that I was able to come up with. Maybe you can reduce it even more, but in my older tutorials, they were probably a little bit more lengthy because I would end up doing a lot of, I would, for example, sculpt all this stuff out here. Well, not sculpt it, but I would kind of draw it out with different sketches, and I'd have a whole bunch of sketches. Now I'm just trying to leverage all the kind of sketches and construction planes from other components because you don't need to make a whole bunch of sketches all the time. So this was a good lesson for me as I keep making this concept in different projects. You end up kind of figuring out like, oh, I guess I don't need to do that step, or I could reduce that step. So hopefully that is helpful for other people too that may be doing it sort of a more sketch approach, with a bunch of different sketches. So I've been applying this to a lot of different projects, like this one here. I also did it to some of the different shapes, like this hexagon enclosure for the circuit playground. If I hide the cover, you can see that there's actually nubs on all the edges. This was actually done not with a mirror, but with a pattern. So you can do a circular pattern across all these as well, using kind of the same techniques. Of course, with a circle, it's a little bit different, but it's totally doable, where you can do these curved nubs. So you can do it that way, and of course the regular rectangle way. And again, the amount of nubs that you have versus the amount of sides that you have all depends on if you're going to actually put a lot of weight on your cover or not. So maybe you don't need so many nubs, but in this case, there's only 2. That's pretty much it, folks. Let me know what you thought in the tutorial. If you have any sort of tips for people, is a great place to drop them and let other people know. Let me guys know if there's any other cool topics you'd like me to cover. But until next time, I'll see you next time. Yeah, I'll see you next time.